the graph of a geometric sequence is shown. So this will be your term number, and this is your term value. Okay, or UN. So state the first 6 terms of that sequence. We've got 4 just from the graph, and you figure out what the next 2 will be. So there's 4 from the graph. So Tn is 2, 4, 8, 16. So obviously we're multiplying by 2 each time. So those are the ones we're filling in there. So our common ratio is 2. Our first term is 2. So Tn will be 2 times 2 to the n minus 1. If the base and the leading coefficient, okay, the initial value are the same, similar as in simplified form, right? Multiplying powers of the same base, you add the exponents. Okay, so notice the shape of it. It's an exponential, right? Keep multiplying by 2. Even if it wasn't a sequence, from this, if you had an n value, if you said n could be any real number, that would be continuing down here, approaching the horizontal axis. But in this case, we keep it in the first quadrant because it's representing a sequence. It's discrete because it's representing the sequence. Okay, so then you're going to graph the next one. Notice how the base of that, because it is a sequence, so for exponential functions, we kept the base being positive. Now we're talking about this as being a sequence. So we can have a negative r value, but you'll notice what it looks like. It jumps, right? And you won't be able to join it up, even if you wanted to. Okay, so plot those.
Okay, if you were to make a sequence out of the terms, or a sequence out of the partial sums out of a sequence, and then add those together, you'd have a series and a series. Is there like a definition for that, like a hyperseries or something?
Definition, no.
And then,
it's a partial series. Some of the. You can get a form. Well, you get a form.
It's a sequence of the terms in a series.
The sums.
Yeah, the sums, the first sums of the series. But then you turn those into terms of their own sequence and make your own series out of series. Right?
Yeah. You get a pattern from that. Yeah. So notice how I'm not going to start at n equals 0. Just because term numbers we consider to be starting at n equals 1. We will look at, as you go on to math, at summation notation. Well, maybe you start at n equals 0. But for now, we're talking about a specific sequence or series, but right now sequence. And so our n is going to start at what? An increase. So that's going to be, our first term then is going to be negative 6. Then it's going to be positive 12. Then it's going to be negative 24. Then it's going to be positive 48. these are going to continue up, these are going to continue down, right? They're going to alternate because of the negative case. Okay, so then working from a graph of a series, the partial sums, okay, so this here, horizontal is n, the vertical axis is the sum. So what's the value of S1? That would be this point here has a value of -2. S2 has a value of +2. S3 is -6. S4 is +10. Okay? So remember what we know. Those are partial sums. The first term and the first sum are exactly the same value. Okay? The second sum is the sum of the first two terms. So if these have to add together to get 2, that must mean that the second term is 4. Okay. S3 are these two added together plus the third term, right? Or you can say S2 plus U3 has to give us this. So 2 plus what gives you -6? -8. Or you can go -2 plus 4 is 2, -8 is -6. And then this plus the fourth term has to give us this fourth sum. So -6 plus what gives you 10? 16. Okay, so series notation and graphic notation. I guess we're just stopping at 4, right? So maybe we go to 4. Okay. So remember to get the sum here, sum of this particular series that make up these terms. We will have, so this will be S4. First term is -2. Then we're multiplying by the R value, which is, so remember R is -2 as well. Actually, we need to do the general case, sorry. So, what's that? That's going to be -3. So -2 over -3 is 2 over 3. We need to keep the -2 in the brackets. Okay, so I'll use big square brackets. And again, what I would just like to use K in here, just to keep it separate from N being the last term. Okay, so that's the series in bracket notation. If it was just the sequence, then we would just find the general term for these. Okay? Then try question 4. So you're given a series 32 plus 8 plus 2. Determine what the fourth term, so they're basically the next two terms in that series. So R is 1/4. So that means U4 equals 1/2. 5 is 1/8. Okay, so what's that? 32 divided by 3 divided by 4. You might think, oh, that means I'm going to get a negative for my sum. I don't have any negatives in those terms there. So, is that wrong that I have that being negative? Adam?
Well, if you, like whenever it's way higher, and then it's made it smaller, it's all getting smaller right now.
Exactly. So, because this R value is less than 1, any raised to any exponent, that value is going to be less than 1. So when you subtract 1 from that, you're going to get a negative 2. So a negative times a negative is a positive. Okay, so that's how you know that that's not wrong to have a negative up front, because this will never be positive. Okay, so in bracket notation, actually, you know what I'm going to do? Well, I'll do this. I'm just going to put this in bracket notation just to save space. K1, and this is technically going to 5, although if it went on forever, it would go to infinity. Okay, so now graphing. So S1, remember, is the same as U1, the first term. So that's 132. Then S2 will be 32 plus 8, which is 40. S3 will be 40 plus 2 is 42. Remember, it's going to approach a value, right, as n goes to infinity, if that R value is less than 1, which it is. So 42 plus a half, we'll just do 42.5. Those go up by 2, so this is, let's see what's coming fit. And then S5 would be 42.5 plus 1/8, which would be what? 42 625. Okay, if we went all the way to infinity, 32 over 1 minus 1/4. It would approach, so 32 times 4 divided by 3, 42.66 is what it's going to equal. Okay. So we're already pretty close, right? It doesn't take long. The smaller the R value, faster we get there. Okay, so that is the end of that booklet. Dr. Mike. Okay, one small booklet